In this problem, we're talking about a disease that begins to spread. Initially, there are 30 people infected, but is projected to grow every day at a rate of 0.25%. Assume growth is not continuous. So we're basically assuming that growth occurs on a daily basis. So we want to write an equation, n of t, that gives the number of infected people as a function of the number of days passed since the 30 people were infected. And I believe this should be t right here. So the number of days t passed since the 30 people were infected. So to write an equation, well, initially there were 30 people. The growth rate is 0.0025, so the growth factor will be 1.0025, raised to the t power to indicate the number of days. In letter B, we want to use logarithms to find the inverse equation t of n. What I'll begin by doing is omitting the function notation to make this a little bit prettier to work with. Next, I'm going to divide by 30 because I want to isolate t. So I have n over 30 equals 1.0025 to the t. Now I'm going to get the exponent down, so I'm going to say t is the exponent on 1.0025 to give me n over 30 by the definition of what a logarithm is. T is the exponent, i.e. the logarithm, on 1.0025 to get n over 30 over here on the left-hand side. Okay, so the question is, what does the inverse equation input and output? Well, on the input side, I have n, inputs n, which is number of people infected, and t is what it outputs, which is the time any given n occurs. So I can basically determine, oh, well, when do I expect 1,000 people to be infected? When can I expect 2,000 people to be infected? So if we do an example, then we can say, well, what about t of, when would I expect 60 people to be infected? Well, now I can figure that out by taking log of 1.0025, 60 over 30, and so I'm going to be finding log base 1.0025 of 2, and I have to use change of base here, so I'll do log of 2 divided by log of 1.0025, and I get t of 60 is approximately 277 days, or 277.6 days for 60 infected to take place. So a long time for the virus to double the number of people it has caught. And so now we really wanted to find t prime of 10. So t prime is what we need to find first, and t prime of n would be, well, here's our function. So in order to do this, we need to identify what kind of formula to use. I'm going to jump over to the next page here. So t is log of 1.0025 n over 30. Well, this has the form log base a n over 30. Excuse me, I'll be consistent. We call it the base b in the exponential, so we'll call it b here as well. And in this case, we don't just have an input variable in the parentheses, we have a function of n. Specifically, we've got to take n divided by 30. So we're going to need to do u prime times 1 over the natural log of b times 1 over u. So in this case, here is our b, here is our u, and we can find the derivative of this, which is really just 1/30th n, and the derivative of 1/30th n is 1/30th, times 1 over the natural log of 1.0025, I don't really need that parenthesis there, times 1 over u, well, u was n over 30. And so now I can do a little bit of simplification here. I have a 30 down here, and I have an n over 30 down here, so those two things will cancel out. And I will be left with 1 over the natural log of 1.0025 times n. And there's my derivative. I'm done with that. That's my t prime. And so now I can find t prime of 10, which is 1 over the natural log of that times n. So I'm going to enter that in. 1 divided by, parenthesis, natural log of 1.0025, close parenthesis, times my n, which is 10 in this case, which is approximately 40.0. And I believe we're asked to interpret this. So to interpret this, we can say that it is expected that when n equals 10 people are infected, well, what to do with this 40? What are the units for it? Well, since this is the inverse function, the derivative of the original function would have been number of people infected per day. Well, in this case, we found the inverse, so this is going to be days per infected. So this is just the inverse of the units as well, or the reciprocal of the units. So what does this mean? It is expected that when n equals 10 people are infected, each additional infected person will take 40 days to occur. I guess this could be better worded, but bottom line is that it's going to be 40 days for one more person to become infected when there are exactly 10 people infected. We would expect this to grow a little bit. In other words, it'll probably become a shorter interval of time for another person to become infected, but because the spread hasn't taken place very quickly yet, we can assume that this will be a slow process.